A planet shrouded in mystery and wonder, Mars has long captured the imagination of scientists and space enthusiasts. As we continue to explore the wasteland, we find more questions than answers. Recently, one of these discoveries shocked the scientific community: the presence of deep, dark clouds scattered across the surface of Mars. First captured by NASA's Mars Reconnaissance Orbiter, (MRO), these black holes are not just unusual, but mysterious phenomena that challenge our current understanding of Martian geography. Could these shadowy holes unlock the secrets of Mars' past, or do they point to a greater mystery beneath the planet's surface? The discovery of these black holes has caused a whirlwind of controversy among scientists. What are these features and how are they created? The first of these mysterious holes was photographed by MRO in 2007, and at first glance many scientists dismissed it as an imaging error. However, further analyses show that this is not a mistake. These black holes are real and spread across the red planet. As more images were released, it became clear that these craters were not isolated, but were distributed in different locations across Mars. This realization deepens the mystery and raises more questions than answers. Many theories have been proposed to explain the formation of these black holes. Some scientists believe that ancient meteorite impacts may have left high-velocity debris in the Martian crust. However, this theory has limitations, as these craters do not show crater walls that are subject to impacts. Another possibility is that these black holes are the remnants of ancient lava tubes that formed during more intense volcanic activity on Mars. If true, it would indicate that these craters are connected to ancient Martian volcanoes, possibly still active underground volcanic systems. A third theory suggests that these black holes are entrances to massive cave systems that have resulted from the slow erosion of rock over thousands of years. These caves may have been formed by water activity on Mars, a fascinating site that can provide evidence of the planet's potential for ancient life. As exciting as these theories are, the mystery of Mars' black holes will only deepen with further research. One of the most confusing aspects of these pits is their depth. Even with high-resolution images, the bottom of these craters is shrouded in darkness, making it impossible to determine their depth. This led to the idea of a steep cliff wall or ridge that blocked the sun and appeared black. Additionally, some black holes are surrounded by icy carbon deposits, especially those near the North Pole. This leads to a connection between these two and the global climate, even its geological role. However, not all black holes exhibit this property, adding another layer of complexity to the puzzle. The ongoing study of these black holes is a testament to the continued growth of science. Each new image taken by MRO and other spacecraft orbiting Mars adds to our knowledge, but also raises new questions. Are these black holes just remnants of Mars' turbulent past, or are they signs of activity beneath the surface? Could it be connected to the mysterious disappearance of Mars' ancient reservoirs, or could it point to something deeper, such as underground reservoirs or networks? As scientists continue to analyze the data and refine their theories, one thing is certain: Mars is far from the dead, barren world we thought. Instead, it's a dynamic, complex planet, full of mysteries waiting to be discovered. In the years to come, we may learn more about these mysterious black holes. As technology advances and future missions, including human exploration of Mars, we may discover the secrets that lie in these empty spaces. Until then, Martian black holes will remain one of the most fascinating and unexplained phenomena in the solar system, an enigma that challenges our scientific and applied understanding. Let us continue to explore the unknown. What is at the end of these holes? Are they just geological features, or do they hold the key to a deeper understanding of Mars' history and life potential? The answers are possible, but for now the mystery remains. The discovery of these black holes on Mars has sparked debate about the history of the Earth and the processes by which the Earth was formed over billions of years. Once thought of as an idle planet, Mars is now a planet with a rich and complex history. These black holes could reveal important insights into the ancient processes that took place beneath the Martian surface. For instance, if these voids are indeed remnants of ancient lava tubes, they could reveal much about Mars' volcanic past, including the possibility that volcanic activity may have persisted far longer than previously thought. This would suggest that Mars was geologically active more recently than we assumed, with potential implications for understanding the planet's habitability and the history of its atmosphere. Moreover, the idea that these black holes might be entrances to vast cave systems is particularly exciting for astrobiologists. Caves on Earth are often home to unique ecosystems, thriving in isolation from the surface environment. If similar cave systems exist on Mars, they could have provided a haven for microbial life during periods when the planet's surface was more hostile. These caves may be humid and hot, to protect life from the harsh conditions above. The discovery of these habitable sites on Mars could prove to be an exciting opportunity and the first evidence of extraterrestrial life. However, confirmation of this theory will require more exploration, possibly involving future missions to explore these dark places and search for signs of life. Black holes also raise questions about the stability of the Martian surface. Some of these craters are thought to be sinkholes, indicating that major changes in the Martian crust are ongoing. Sinkholes are usually formed when underground holes collapse, often due to the dissolution of molten rock by water. On Mars, the same thing happens, especially when there is a lot of liquid water. This theory is interesting because it points to a dynamic subsurface environment, where water and other fluids can still interact with the Martian crust. If so, understanding these interactions will be crucial for future missions aimed at finding life or colonizing Mars. Adding to the puzzle is the discovery that some black holes are surrounded by large deposits of carbon dioxide, particularly in the polar regions. Carbon dioxide, found on Mars as dry ice, may have played a role in the formation or development of these craters. For example, the melting of dry ice can contribute to the erosion of the surrounding rock, which will enlarge these holes over time. For example, the presence of carbon dioxide indicates that these sediments are part of larger, more complex geologic structures that contain other volatile compounds. Understanding the role of carbon dioxide in this context can provide important clues about the history of Mars' climate and its ability to support life in the past and even today. The continued discovery of new black holes on Mars, recorded by various spacecraft, indicates that these phenomena are more common than previously thought. This has led scientists to believe that the crust of Mars is full of these holes, many of which are unknown in size and location. If true, it would dramatically change our understanding of the surface and subsurface structures of Mars. It also raises important questions about the safety of future missions to space, especially human exploration. Therefore, understanding the distribution and nature of these black holes is not only a matter of scientific understanding, but also of concern for planning future operations. As we continue to study these black holes, we are reminded of how little is known about Mars. Each discovery, while providing new insights, also challenges our current theories and forces us to rethink our thinking about the red planet. Black holes on Mars are not the only terrestrial phenomenon. A window into the world's past and future. Whether they are remnants of ancient volcanic activity, evidence of past water flows, or something else, these craters hold the key to unlocking the mysteries of Mars. In the coming years, as new missions are launched and our understanding deepens, we may solve the mystery of these mysteries. Until then, Martian black holes remain one of the most intriguing mysteries in the solar system.